The modern industrial war machine is a colossal assembly of moving parts, but its ultimate point of failure is often a microscopic steel sphere. During the Second Global Conflict, as nations mobilized millions of men and synthesized entire industries, the physical mechanics of warfare became bound to a singular, unyielding engineering bottleneck: the precision ball bearing. Every rotating shaft, every high RPM supercharger in an aircraft engine, every tank turret gear, and every naval gyroscopic compass depended absolutely on these frictionless chromium steel assemblies. Without them, metal surfaces grinding under intense friction would weld themselves together within minutes of operational use, rendering the most advanced tanks, bombers, and submarines into useless mounds of static iron. The manufacturing of these bearings required an extraordinary level of metallurgical purity and dimensional precision, with tolerances measured in millionths of an inch. While the United States Army Air Forces launched hundreds of heavy bombers into the flak-filled skies of Germany to obliterate the Reich's bearing manufacturing hub at Schweinfurt, the Allies were silently confronting a terrifying domestic crisis of their own. They were rapidly running out of the very same precision bearings required to keep their own air forces flying, and the key to their survival lay in the hands of a neutral Scandinavian nation and a small fleet of high-speed civilian smuggler boats. This is the story of how the British Ministry of Supply and a daring group of merchant mariners ran the German blockade of Sweden to secure the metallurgical lifeline that kept Allied wings in the air, revealing that the strategic bottlenecks of industrial war were a mirror image shared by both sides of the conflict. To comprehend the sheer scale of the Allied bearing deficit in 1943, one must look at the mechanical anatomy of a combat aircraft like the Avro Lancaster or the Supermarine Spitfire. The Merlin Vi-12 engine, the mechanical heart of British air power, utilized precision-engineered ball and roller bearings to support its crankshaft, drive its dual-stage supercharger, and operate its fuel pumps at speeds exceeding 24,000 revolutions per minute. At these extreme velocities, any microscopic impurity in the steel or any slight imperfection in the sphericity of the bearing would cause instantaneous catastrophic failure, resulting in the engine tearing itself apart in mid-flight. Furthermore, the hydraulic gun turrets, the bomb release mechanisms, the flight control pulleys, and the navigational instruments each required specialized bearing sizes that domestic British industry, heavily battered by the Blitz and suffering from a severe shortage of specialized machine tools, simply could not manufacture in sufficient quantities. The British Ministry of Aircraft Production computed that by the spring of 1943, the demand for high-precision miniature bearings had outstripped domestic supply by over 40%. The United Kingdom was facing a silent paralysis of its aircraft production lines, a bottleneck so severe that it threatened to halt the strategic bombing offensive against Germany just as it was reaching its peak. The Allies could build thousands of airframes, but without the tiny frictionless steel spheres to guide their mechanical joints, those airframes would remain grounded, dusty monuments to industrial overreach. The strategic focus of the Allied economic warfare departments had long been fixed on Germany's bearing factories. Air power theorists like General Karl Spaatz believed in the strategic node doctrine, which posited that by destroying a single, highly concentrated industry, the entire enemy military infrastructure would collapse. Schweinfurt, a small Bavarian town on the Main River, was identified as the ultimate target, as it produced over 50% of Germany's precision ball bearings. The resulting raids of August and October 1943, which saw hundreds of American B-17 flying fortresses shot down by Luftwaffe fighters, did indeed inflict severe temporary damage on the Kugelfischer and Fichtel and Sachs plants. However, the American theorists had fallen victim to what historians now call the ball-bearing illusion. They assumed Germany was a closed industrial loop with a single point of failure, failing to realize that Albert Speer, the German armaments minister, had already begun a massive program of industrial decentralization, substituting plain bearings where possible and importing massive quantities of high-grade bearings from neutral Sweden. More importantly, the Americans did not realize that their British allies were just as dependent on external bearing supplies as the Germans were. While American bombers were dying in the skies over Schweinfurt to stop German machines from turning, British diplomats were pleading with Swedish industrialists to keep British machines rotating. The critical link in this silent industrial war was the Swedish conglomerate Svenska Kullagerfabriken, universally known as SKF, which controlled the world's most advanced bearing factories and possessed the unique metallurgical secrets required to produce the highest quality chromium steel. The geopolitical position of Sweden during the Second World War was a delicate and often cynical balancing act. Surrounded by German-occupied Norway to the west, German-occupied Denmark to the south, and a battle-ravaged Finland allied with the Axis to the east, the Swedish government in Stockholm was acutely aware that its survival depended on its economic utility to the warring powers. Sweden possessed some of the richest and highest purity iron ore deposits in the world at Kiruna, but its crown jewel was SKF. Headquartered in Gothenburg, SKF was a multinational giant with manufacturing subsidiaries in Germany, Great Britain, and the United States. This unique corporate structure placed the Swedish directors of SKF in an extraordinarily powerful position. They supplied both the German Wehrmacht and the Allied air forces with the critical mechanical components of war, operating as a commercial sovereign that transcended the bloody front lines of Europe. For the Germans, Swedish bearings and high-grade bearing steel were indispensable, representing nearly 60% of their high-precision imports. For the British, SKF's specialized factories in Sweden were the only source of miniature instrument bearings and ultra-high-grade steel wire needed for valve springs in high-performance aero engines. The physical barrier preventing the British from accessing these Swedish resources was the Skagerrak, the narrow strait between Denmark and Norway that connects the North Sea to the Baltic. Following the German invasion of Denmark and Norway in April 1940, the Kriegsmarine had established a dense naval blockade across the Skagerrak, complete with deep minefields, coastal artillery batteries, and continuous aerial patrols by Luftwaffe Ju-88 bombers. This blockade, known as the Skagerrak Barrier, completely severed Sweden's maritime trade with the Western world, locking Swedish shipping inside the Baltic and forcing Stockholm to conduct the vast majority of its trade with the Axis. For the first 2 years of the war, the British had tried to run this blockade using standard merchant vessels during the dark winter months, but the losses had been catastrophic. The German naval patrol network was too dense, and the slow, lumbering cargo ships were easy prey for U-boats and coastal aircraft. By the winter of 1942, the British Ministry of Supply was desperate. The shortage of Swedish steel wire and precision ball bearings had reached an acute crisis point, threatening to shut down Spitfire production within months. British aircraft factories were cannibalizing older airframes for parts, and the quality of domestic bearings was declining, leading to an increase in engine failures. The British government realized that if they could not break through the Skagerrak barrier, their air offensive would grind to a halt. It was against this background of industrial desperation that the British Ministry of Supply, in close coordination with the Royal Navy and the Special Operations Executive, conceived one of the most unorthodox and secretive maritime logistics programs of the war, Operation Bridford. The mastermind behind the operational logistics was Sir George Binney, a colourful and highly resourceful British diplomat and explorer who had previously organised successful blockade-running operations from Sweden using trapped Norwegian merchant ships. Binney's new plan was as simple as it was daring. Rather than using large, slow merchant ships that would be easily intercepted by German patrols, the British would construct a flotilla of small, ultra-high-speed vessels that could slip through the shallow coastal waters of the Skagerrak under the cover of long winter nights. These vessels would be designed to carry high-value, low-weight cargoes, specifically focusing on the highest priority precision ball bearings, machinery parts, and specialized Swedish steel wire. The cargo capacity of each ship would be small, but the cumulative impact of several successful runs would be enough to meet the entire deficit of the British aircraft industry. The project required the coordination of naval architects, diplomatic negotiators, industrial leaders, and elite merchant crews willing to sail unarmed into some of the most heavily patrolled waters in the world. The construction of the blockade-running fleet was a marvel of improvisational engineering and wartime secrecy. Under the cover of a program to build fast motor gunboats for the Royal Navy, the Ministry of Supply ordered 5 specialized vessels from the shipyard of Camper and Nicholson's in Gosport. These vessels, which became known as the Gay Viking class, were originally designed as diesel-powered motor gunboats, but they were radically modified for their cargo-carrying role. The heavy armament, gun turrets, and military crew quarters were eliminated, creating a small, highly streamlined cargo hold capable of carrying roughly 40 to 45 tons of freight. To ensure maximum speed and maneuverability, each vessel was powered by 3 massive Paxman Ricardo diesel engines, generating a combined 3,000 horsepower and allowing the ships to reach speeds exceeding 28 knots. This high velocity was critical, as it would allow the vessels to cross the North Sea and traverse the most dangerous sectors of the Skagerrak blockade in less than 8 hours of darkness. To minimize diplomatic complications with neutral Sweden, the vessels were registered as civilian merchant ships owned by the Ellermans Wilson Line, and they flew the red ensign of the British Merchant Navy. The crews were recruited entirely from volunteers within the Merchant Navy, men who were chosen for their exceptional seamanship, physical toughness, and ability to keep a secret. They were paid double wages to reflect the extreme danger of the mission, and they were forbidden from wearing military uniforms or carrying any identification that would link them to the British government. If captured by the Germans, they would be treated as civilian smugglers rather than prisoners of war, facing the very real prospect of execution or imprisonment in concentration camps. The vessels themselves were named the Gay Viking, the Gay Corsair, the Nonsuch, the Hope, and the Master Standfast. Each ship was equipped with state-of-the-art navigational radar, muffled exhausts to suppress engine noise, and low-visibility paint schemes designed to blend into the grey, misty waters of the North Sea. The operational base for Operation Bridford was established at the port of Hull on the east coast of England. From here, the blockade runners would depart during the dark winter months when the nights were longest and the frequent North Sea gales and heavy sea mists provided the best natural concealment from German radar and air patrols. The destination was the tiny, picturesque fishing village of Lysekil on the western coast of Sweden, located just north of Gothenburg. Lysekil was chosen because it possessed a deep, sheltered harbour that was relatively isolated from the main German intelligence networks in Gothenburg, and it was connected by rail to the SKF manufacturing plants. British agents in Sweden, working under the cover of consular officials, had secretly negotiated with Swedish local authorities and SKF executives to coordinate the arrival of the ships. Trains loaded with tons of high-precision ball bearings and steel wire were scheduled to arrive at the Lysekil docks precisely when the British vessels were expected to slip into the harbour, ensuring that the cargo could be loaded and the ships dispatched back to sea in less than 36 hours. The first operational season of Operation Bridford commenced in the autumn of 1943, under the direct command of Sir George Binney, who sailed aboard the Gay Corsair as the commodore of the flotilla. The journey across the North Sea was a terrifying test of endurance and seamanship. The North Sea in winter is one of the most hostile maritime environments on Earth, characterized by freezing temperatures, massive swells, and blinding snowstorms. For the crews of these small, lightweight motor vessels, the physical battering was relentless. The boats pitched and rolled violently in the heavy seas, and the freezing spray instantly turned to thick ice on the decks and superstructures, threatening to capsize the vessels under the weight of the ice. To avoid detection by German radar stations situated along the occupied Norwegian and Danish coasts, the blockade runners had to maintain absolute radio silence and sail without any navigation lights, navigating solely by dead reckoning and the crude radar systems of the era. As the vessels approached the Skagerrak, they entered the most perilous phase of the run. They had to navigate a narrow corridor of coastal waters, dodging German minefields and slipping past German naval patrols that were actively searching for any blockade-running activity. The German Kriegsmarine had deployed dozens of armed trawlers, fast patrol boats, and coastal radar stations specifically to seal the Skagerrak barrier. On several occasions, the British crews could see the searchlights of German patrol boats sweeping the water just miles away, or hear the roar of Luftwaffe night fighters flying overhead through the clouds. The high speed of the gay Viking class was their primary defence. If spotted, they would open up their 3 Paxman Ricardo engines to full throttle, leaving a massive white wake as they fled into the darkness at nearly 30 knots, outrunning the slower German patrol vessels. Despite the extreme hazards, the gay corsair successfully slipped into Lysekil harbour on the night of October 31st, 1943, marking the first successful run of Operation Bridford. The local Swedish population, many of whom were deeply sympathetic to the Allied cause, welcomed the British mariners with warmth and assistance, despite the official stance of strict neutrality maintained by the Stockholm government. Over the next 48 hours, the Swedish dockworkers worked with feverish speed to load the vessel's holds with 40 tons of SKF ball bearings, precision machinery components, and high-grade steel wire. The gay corsair then slipped back out into the Skagerrak, successfully running the German Gauntlet a second time and arriving safely in Hull to a triumphant but highly secretive welcome. Over the course of the winter of 1943 to 1944, the flotilla completed several more successful round trips, delivering a cumulative total of nearly 350 tons of priceless metallurgical and mechanical cargoes directly to the British war effort. The operational success of Operation Bridford was not without its tragic costs. The Master Standfast, commanded by Captain C.R. Holdsworth, was intercepted by a German armed trawler during a run in November 1943. Due to a mechanical failure in one of her diesel engines, the vessel was unable to outrun her pursuer and was fired upon by the German ship, resulting in the tragic death of her chief officer and the capture of the remaining crew. The survivors were imprisoned in Germany for the remainder of the war, a harsh reminder of the unforgiving stakes of this industrial smuggling operation. Additionally, the extreme mechanical strain placed on the highly stressed Paxman Ricardo diesel engines meant that the vessels were frequently sidelined in Hull for extensive maintenance and repairs, reducing the overall frequency of the runs. Yet the physical tonnage of material that did arrive in Hull was of immense and disproportionate strategic value. To understand the true impact of these 350 tons of smuggled Swedish cargo, one must analyse the specific industrial calculations of the British aircraft sector. A single ton of miniature precision instrument bearings contained over 100,000 individual units. Therefore, the cargo delivered by the blockade runners represented millions of individual bearings, enough to supply the entire British aircraft instrument and electrical component industries for nearly 9 months. Furthermore, the high-grade Swedish valve spring wire delivered by the ships was of such superior metallurgical quality that it reduced the failure rate of Spitfire and Lancaster engine valves by over 80%. Prior to receiving the Swedish wire, British engine manufacturers had been forced to use inferior domestic steel alloys, which suffered from rapid metal fatigue under high temperatures, leading to frequent engine seizures during combat missions. The import of Swedish steel quite literally saved the lives of hundreds of Allied airmen by keeping their engines running over the skies of occupied Europe. The mathematical counterfactual of Operation Bridford reveals the true fragility of the Allied air offensive. Had Sir George Binney's blockade runners failed, or had the Swedish government succumbed to intense German diplomatic pressure to shut down the Lysekil smuggling route, the consequences for the Allies would have been catastrophic. The British Ministry of Aircraft Production calculated that without the SKF miniature bearings and Swedish valve spring steel, the production of new combat aircraft would have dropped by 30% between November 1943 and June 1944. This would have resulted in a deficit of over 2,000 high-performance fighters and bombers just as the Allies were preparing for the invasion of Normandy. The strategic bombing offensive, which relied on maintaining a continuous, overwhelming volume of aircraft to saturate German air defenses, would have been severely crippled, potentially delaying the invasion of Europe by a full year and giving Germany precious time to mass-produce its own revolutionary jet fighters and V-weapons. The legacy of Operation Bridford and the battle for Swedish ball bearings challenges the conventional narrative of Allied industrial invulnerability. It demonstrates that the global conflict was not simply a battle of raw industrial volume, but a highly complex and fragile struggle over specialized technological nodes and rare metallurgical resources. While Allied propaganda painted a picture of an unstoppable arsenal of democracy that could outproduce the Axis by sheer force of numbers, the physical reality was that the entire Allied war effort was highly vulnerable to the disruption of a few critical supply lines and specialized components. The small, fast and unarmed motor vessels of the gay Viking class slipping through the cold, mine-strewn waters of the Skagerrak proved to be just as vital to the Allied victory as the massive assembly lines of Detroit or the heavy bomber fleets of the 8th Air Force. In the final analysis, the ball-bearing illusion was a lesson in the interconnectedness of the modern industrial world. Both Nazi Germany and the British Empire, despite their massive size and resources, were ultimately dependent on the specialized skills and raw materials of a tiny, neutral Scandinavian neighbor. The silent, high-stakes smuggling operation out of Lysekil ensured that the friction of war did not grind the Allied military machine to a halt. As we look back at the grand strategic maps of World War II, with their massive arrows indicating the movements of armies and fleets, we must remember that the success of those grand maneuvers was ultimately decided by the silent, reliable rotation of millions of tiny steel spheres smuggled across the North Sea in the dark holds of 5 small British motorboats.